as many videos as I've done about virtualized gaming PCs, people have asked, how long am I going to milk this concept? I think I can get at least a couple more. Did you know that 2 out of every 3 men will experience some form of male-patterned baldness by the time they're 35? Every network admin worth his weight in scotch knows the value of preventative maintenance. So why not apply that same mindset to your hair? That is where Keeps comes in. Keeps is a subscription service designed for men who are dealing with premature deforestation. With Keeps, a licensed doctor will review your information online and recommend the hair loss treatment that's right for you. And don't worry about forgetting your prescription at the pharmacy while you're on a beer run. Instead, your prescription will be shipped to your door every 3 months. Now, the hair on top of my head is so thick I can barely get a comb through it. Seriously, my barber charges me double, and I want to do my best to keep him employed. Keeps uses generic FDA-approved medications, and since there's no name brand markup, you'll save money while keeping your barber in business for years to come. If you're ready to take action and prevent hair loss, go to keeps.com/craft or click the link down in the video description and receive 50% off your first order. That's keeps.com/craft, and thanks again to Keeps for sponsoring today's video. Sorry, I was enjoying that beer so much I forgot that I needed to film something. Welcome back to Craft Computing, everyone. As always, I'm Jeff, and this is the cloud gaming PC that I built just a week ago for less than $1,000. And I get a lot of questions as to what actually is a cloud gaming PC. This is not a PC that you build to be able to hook up a monitor and keyboard to and play games on it. Rather, this is meant to be a distributed computing system. A server that you can place in the corner of a room, hook it up to network, and then stream games to it to devices as simple as a laptop, a Chromebook, or even a Raspberry Pi. What that means is you don't have to build every single person in your household a PC who wants to get into PC gaming. Instead, you can have a single system to run everything. Last week, we focused on the hardware section of this, that is, putting everything together and making sure we have enough power to run 4 1080p gaming sessions at the same time. Today, I'm going to focus on the software aspect, what's required, and how you can get up and running yourself. As a quick refresher, this system is running an Intel Xeon E5 2690 V3 12-core 24-threaded processor on a Jingsha X99 motherboard. We've got 2 nVidia Tesla M40 Enterprise GPUs with 24 gigabytes of video memory each. On top of that, we have a 1TB NVMe drive and 64 gigabytes of system memory. Now, one thing I've removed from the system for right now is the giant blower fans that were keeping the Tesla M40s cool. This system will not be able to run games without some active cooling on those cards, but if these were plugged in, you wouldn't be able to hear a word I was saying. In a future video, I am going to try one last time to cool these graphics cards and make it room-friendly, so you can keep it in a living room or a bedroom and not lose your mind. To get started, there's only a couple pieces of software that you'll need to get. For starters, we're going to install Proxmox 7.1, which as of the filming of this video is the latest version. You'll also need to create an NVIDIA Enterprise account and apply for a trial license for their virtual workstation software. This is actually the software pack that we will be using to enable vGPU support on our definitely not enterprise hardware. Last but not least, you'll need to download the Pve headers that match the kernel version that you have inside Proxmox. Now, this can normally be done through the apt repository, and even though Proxmox 7.1 is using the 5.13 Linux kernel, the latest version in the repo is only 5.11, so a manual download is required. Links for where to download all of the required files will be down in the video description. And with all the prerequisites out of the way, let's go ahead and get started. On the system right now is a 100% clean install of Proxmox 7.1, and we're going to start off by installing all of our required software. Lucky for you, I've set up a text file where you can simply copy and paste pretty much everything in the instructions. Again, link is going to be down in the video description. To start off, we're going to set up the non-subscription repository for Proxmox to make sure our system can stay 100% up to date. There we go. Then, as you should on any new install, we're going to do an apt update, followed by an apt upgrade. Once everything is up to date, we do have a couple required packages, and that includes Git, Build Essential, Pve Headers, DKMS, JQ, and mdevctl. We'll also need to clone a couple Git repositories, starting with the secret sauce for this whole thing, which is the vGPU unlock script by Dual Coder. There's also a new Rust-based script by user mbilker, and that is the vGPU unlock RS, so go ahead and clone that repository as well. And since the Rust script requires Rust, we should probably install Rust, and that can be done with a very simple curl and sh command. We're going to select 1 to proceed with the installation, and then just wait for it to finish. Last but not least are the 2 packages that we had to download manually. So here we have the nVidia vGPU driver, which is just a 30 megabyte driver file, and also the Pve headers for the current kernel version, which is 5.13.19-2. And we're going to simply copy those over using WinSCP. With all the required packages ready on the system, we can start moving to system configuration, and the first of which is enabling IOMMU and PCI Express pass-through. To do that, we're going to edit our grub file, so we're going to type in nano/etc/default/grub. Scroll down to the line that says grub command line Linux default, and we're going to comment that out with a £, or a hashtag. Then, depending on your CPU architecture, we're going to copy in either the Intel or AMD IOMMU setup. In my case, I'm running an Intel Xeon CPU, so we're going to use quiet Intel IOMMU on. And inside Nano, hit Ctrl-X to exit, Y to save, and Enter to confirm the file name. To apply those changes, we're going to type in update-grub. There are also some required modules for this that we need to start up at boot. So again, we're going to type in nano and then etc/modules. It should bring up a file that looks like this, essentially blank with some commented outlines at the top. And we're going to copy over the VFIO modules that are required. So VFIO, VFIO IOMMU Type 1, VFIO PCI, and VFIO VIR-QFD. And again, Ctrl-X to exit, Y to save, and Enter to confirm the file. One of the things included in the Linux kernel is the Nuvo driver, which is essentially an open source replacement for NVIDIA graphics drivers. But as we're going to be using an official NVIDIA graphics driver, we don't want that one working. So we're going to blacklist that by typing in the following command. That is echo blacklist Nuvo, and we're going to place that in etc modprobd/blacklist.conf. And to apply that change, we're going to type in update-init-ramfs space and then -u. This will update all of the changes that we just made to the kernel and let us proceed to the next steps. Once the update is done, we're going to do a quick system reboot. So, reboot. Once your system has booted back up and you've reconnected with SSH, we can move on to the really fun part, which is the configuration of the NVIDIA drivers. First thing that we need to do is install the Pve headers that we should have installed before I rebooted the system, but we can go ahead and do that now. To do that, we're going to type in dpkg-i, followed by the Pve header file name. Next, we need to make the NVIDIA vGPU unlock script, as well as the NVIDIA driver installation executable. So we're going to type in chmod-r+x, and then vGPU_unlock for the directory. And then chmod+x, followed by the NVIDIA installation package. With that done, we are ready to install our NVIDIA driver. So we're going to execute that by typing in a period and a /, followed by the NVIDIA package installer file name, but then we're going to add --dkms to install this as a kernel module. Inside the installer, you'll just have to answer a couple quick questions, starting with, would you like to register the kernel module as a source with DKMS? And yes, we would. When that's all done, you should see a message that says installation of the NVIDIA module is now complete, and go ahead and click on OK. Inside the newly created driver files, there are a couple of lines of code that we need to change to hook them into the NVIDIA unlock script. First of which is going to be modifying the file at user source nvidia-510.47.03, or the driver version that you just installed, /os-interface.c. And this one is pretty simple. We're just going to scroll to the bottom of the include lines and paste in the following line from the vGPU unlock script to include a C file within that directory. And yet again, hit Ctrl-X to exit, Y to save, and Enter to confirm the file. Next up, we're going to add a line of text to another file, and this one is in user source nvidia 510.47.03 /nvidia.kbuild. For this one, we're going to scroll all the way to the bottom of the file and paste in the following line. And yet again, Control X, Y, and Enter. With those 2 lines added, we can run our Rust installer and complete the vGPU unlock installation. To do that, we're going to go into the Rust directory, so cd vGPU _unlock -rs. Then you're going to type in cargo build -- release. Next up, we need to make a vGPU unlock service, so the service will actually start up when the PC does. To do that, we're going to create a couple directories, starting with nVidia vGPUd.service.d and the nVidia vGPU manager.service.d. Inside both of these directories, we're going to create a vGPU unlock.configuration file, and that can be done by typing in nano followed by the directory and vGPU unlock.conf. And inside these files, we're going to paste the following line so it will actually start up the vGPU unlock service. Yet again, Control X, Y, and Enter. And we're going to do the same thing for the vGPU manager service. Paste in the same line, Control X, Y, and Enter. With all that done, our vGPU driver should now be installed and running, but we do need to reboot the system first, so go ahead and do that now. Yet again, with your system booted back up and reconnected to SSH, we can verify that the NVIDIA vGPU unlock script is actually working. To do that, we're going to use the utility mdevctl, which is a program that will let you split out different aspects of your hardware, including NVIDIA graphics cards. To view our available profiles, I'm going to type in mdevctl types. And hopefully, I get this list right here, which displays all of the possible bifurcations of our NVIDIA cards. If you see a list that looks something like this, congratulations, vGPU profiles are now unlocked and ready for you to use. If you don't see any output from this command, you'll want to go back and check all of the steps from this tutorial. With all that out of the way, we're going to move away from the SSH session for a little while and focus on the web GUI. The next step is setting up a Windows VM, but before you can do that, you likely need to upload a Windows ISO so your virtual machine has something to boot off of. To do that, click on the local storage from your Proxmox server, and then go over to ISO images and click Upload. Now, I can't supply you with a download link for a Windows ISO, but pretty much any Windows ISO will work. So upload whatever you have, and we'll move on to the next step. To create our Windows VM, I'm going to right-click on the Proxmox server and go down to Create VM. First couple things you'll need to do is create a VM ID, which is a 3-digit number, and this can be pretty much anything you want. So I'm going to type in 501, and then give your VM a name. I'm going to name this one M40-001. Click on Next to go to our operating system setup, and this is where you will link the ISO file you just uploaded to this virtual machine in order to boot off of it. However, I'm not going to use that method. I'm going to say do not use any media because I plan on booting off of my Windows deployment server. And if you're curious on how you can deploy Windows through the network, I do have a tutorial for that, and I'll link it right up there. Under Guest Type, go ahead and click on the drop-down window and go to Microsoft Windows, and then click on Next. Starting with Proxmox 7.1, it will default to creating a virtual machine with whatever the native BIOS of your hardware is using. You should be using a UEFI BIOS if you plan on running this tutorial, which I probably should have mentioned at the beginning, but it is at the beginning of the notes that you can download from the video description below. If not, go ahead and make sure your virtual machine is set up using a UEFI BIOS by clicking on the Q35 for machine type and OVMF UEFI under the BIOS dropdown. You'll also need to add an EFI storage disk, and for this, we're just going to add that to our local repository. If you're running a default Windows 11 installer, you'll also have to define a TPM storage directory. However, if you have a modified Windows 11 installer that doesn't require TPM or are using Windows 10, just uncheck the Add TPM box. With all that done, go ahead and click on Next. The next page is where you're going to set up your hard drive capacity for your virtual machine. Now, I'm using a 1TB NVMe drive for these 4 virtual machines, so I'm going to give each one a 200 GB max capacity. With that set, go ahead and click on Next. Now again, this system is using a 12-core, 24-threaded CPU, and since I'm going to be splitting this up 4 ways, I'm going to give each system 6 CPU threads to work with, and that goes under the CPU cores. Next up is the amount of system memory you want to assign to each virtual machine, and I'm going to give each of these gaming machines 12 gigs, so 12,244. Under Network, leave it with the default Intel E1000 adapter, click on Next, and then click on Finish. You should now see a new virtual machine showing up under your Proxmox server. Go ahead and double-click that VM to open up a VNC window, start up your virtual machine, and install Windows as you normally would. Once you have Windows installed, go ahead and shut it down. That way we can attach our virtual graphics card. And since I'm an overachiever, I went ahead and installed 4 Windows VMs. Now that we have Windows set up and our NVIDIA driver loaded, we come to the very tricky part, and that is, how do we actually configure our NVIDIA virtual graphics card? And what even is a virtual graphics card? With a virtual GPU-enabled card, you're able to actually divide your graphics cards into equal chunks and present them to a virtual machine as if a graphics card was physically plugged in. That is, giving a VM direct hardware access. The easiest way to explain this is, let's say you have an 8GB graphics card. You can divide that card into 8 equal chunks with 1GB of video memory each, 4 2GB chunks, 2 4GB chunks, or 1 8GB chunk. The amount of video memory and the features you have available from the graphics card to the virtual machine are determined by what NVIDIA vGPU profile you enable, and these profiles are what we listed out before using the mdevctl utility. If we go over to NVIDIA's website, you can see that there are a number of cards that support vGPU modes, but pretty much all of them are either Tesla or high-end Quadro cards. We have cards like the Quadro RTX 8000, the Tesla V100, the Tesla P100, or the Tesla M60. Now, if you note, the Tesla M40 that I have installed in this system right now is not on this list, and that's where the vGPU unlock software comes into play. It allows pretty much any architecturally compatible graphics card to use vGPU modes, so that is any Maxwell, Pascal, Turing, or Volta-based GPU. Using the mdevctl types utility, you can view all of the available profiles for your particular graphics card. In my case, the Tesla M40 is a Maxwell-based card, and so we see the profiles for an M60-based GPU. I've gone ahead and highlight the NVIDIA 18 profile, which is a Maxwell-based profile with 2GB of video memory. You can also see that it has a frame rate limiter enabled of 60 frames per second, and has a max resolution of 5K by 2880, and a max number of instances of 4. On a GPU, you can only use a single profile type, so you can't mix and match NVIDIA Profile 18 with NVIDIA Profile 22 to get different sized virtual machines. Using this NVIDIA 18 profile, I could create up to 4 2GB virtual GPU cards and assign each card to its own virtual machine. Each VM would have access to 2GB of physical memory and could use up to 100% of the GPU's other resources, such as NVENC encoding or CUDA cores. Now, unfortunately, you can't mix and match profiles on a single GPU. So in this case, if I assign the NVIDIA 18, I have to use NVIDIA 18 for all GPU instances. And this has a max number of instances of 4, so I can only create up to 4 2GB cards. The Tesla M40s, though, have 24GB of memory, so a lot of that memory would just be sitting there wasted. That max number of instances has to do with the maximum available memory on supported NVIDIA graphics cards. And since the Tesla M60 and M6 are the only Maxwell-based cards that support vGPU, they are only 8GB, so they figured they would never need to support anything more than 8GB with these particular profiles. Luckily, the new vGPU Unlock RS script allows us to modify these vGPU profiles and define all the parameters ourselves, and that's what we're going to set up now. First thing I need to do is create a new directory to hold all of my vGPU unlock profiles. So I'm going to mkdir to create the directory, /etc/vGPU unlock. Then we create a configuration file that holds all of our profile overrides. So that is going to be in vGPU unlock /profileoverride.toml. Now again, you're probably just going to want to copy and paste my profile data from the instruction file down in the video description. I've gone ahead and copied off my profile 18 data, and we'll paste that into the new file. Now there's actually quite a bit to go over in just this very short configuration file. Starting all the way at the top, we are going to modify profile NVIDIA 18. Again, the NVIDIA 18 profile is only for Maxwell-based GPUs, which my Tesla M40s are. You may have a different vGPU profile that you need to modify. If so, you can follow this as a template, but you will need to make sure to enter your own information. The first line I've added here is the number of supported displays, and I've set this at just 1. Now by default, this profile actually enabled up to 4 virtual displays, but we're just using this as a gaming PC, so 1 display will be just fine. Next up, we have our supported resolution, which is defined by width and height, and I have set at 1920 by 1080. Again, the default resolution support is 5120 by 2880, so why would I lower that down from 5K to just support 1080p? It's actually pretty simple. If you plug in a 5K display to a PC, it will try to default the resolution all the way up to 5K. And sometimes games will see this default resolution and try to set their own resolutions to 5K, which often leads to crashes. So I actually recommend setting your maximum resolution in a profile to something like 1080p or 1440p or even down to 720p if you're aiming for lower resolution streaming. The last line for the display is the max number of supported pixels, and this one's actually pretty easy for you to figure out at home. Just take your width, multiply it by your height, and you get the maximum number of pixels. Next up is Cuda Acceleration on or off. I went ahead and turned mine on by setting the value to 1. FRL is a frame rate limiter that you can enable inside the NVIDIA driver itself, and I would actually recommend turning this on, as you're probably not aiming for super high frame rate gameplay on a remote machine from a desktop in the other room. Secondly, by capping your gameplay to 60 frames per second, you'll actually save resources on the PC and allow more people to play on the same graphics card. Up next is the frame buffer, and this especially matters for older graphics cards like the Tesla M40 or newer generation graphics cards that have more video memory than their consumer counterparts. In the case of my Tesla M40s, they have 24 gigabytes of video memory each. However, Maxwell cards are limited to distributing 8 gigabytes of video memory per card, which leaves 16 gigabytes unutilized. By modifying this value, I can change the amount of physical memory that we are passing through to a virtual machine instead of the default 2, 4, or 8 gigabytes available to Maxwell cards. In fact, you can assign all 24 gigabytes of this card to a single profile if you really wanted to. In my case, I'm going to split the card pretty much down the middle and give each profile 12 gigabytes of VRAM to work with. Down in the video description and the instruction file that you should have been using to this point, I have a full list of VRAM sizes that you can paste in. And last but not least is the Pci ID. Now, the reason we need to change the identifier of the vGPU is vGPUs actually require licensing by nVidia. The vGPU unlock script is allowing consumer or non-certified NVIDIA cards to utilize vGPU drivers. Now there's 2 pieces to the Pci ID equation. There's the device ID and the subsystem ID. If we look here at my configuration file, the 17F0 is the device ID, and the 11A0 is the subsystem ID. When you look these up online, these are normally presented following the vendor ID, and in NVIDIA's case, that is 10DE. In here, though, we don't want the vendor ID, we want the device ID and the subsystem ID as one single line. And I know it's a little bit confusing, but don't worry. Again, down in the instructions you can get in the video description, I have a full list of Maxwell, Pascal, Volta, and Turing-based cards that you can get the device IDs for. Just copy the values that match the architecture of the graphics card you're using, and since I'm using the Tesla M40, I have a Maxwell-based card, so I'm using the Quadro M6000. Once you have that pasted in, we can exit and save. So, you've created your vGPU profile, what are you gonna do next? Well, let's attach the vGPU to a Windows VM and play some games, because that's kind of the whole point of this, right? As you can see, I've set up 4 Windows virtual machines right here, and there's really only one thing you need to add to these VMs to allow them to use virtual GPUs, and that is a unique identifier, or UUID. Now, unfortunately, I haven't found a way to do this in the GUI, but getting to the configuration file is simple enough. We're going to type in nano/etc/pve/qemu-server/ and then the VM ID number, so in this case 501.conf. And this part could not be simpler. First off, we're going to create a new line of text and paste in argument-UUID followed by a long string of numbers. However, it's only the last 3 that you need to worry about, and all we're going to do is replace those 3 pound signs with the VM ID number of our virtual machine, or 501. Control X, Y, and enter. Over in the web interface, I'm going to click on VM 501. I'm going to go down to Hardware, and then add a new PCI device. Under Device, I'm going to grab that pull-down menu and scroll down to our nVidia Tesla M40. Then under MDev type, I'm going to select nVidia Profile 18, which you'll remember is the profile that we've modified. I'm going to click on Add, and then I'm simply going to open up this VM and start it. Now over on the SSH side of things, there's a really nifty command that you can use to view the process of a virtual machine and a vGPU. We're going to say watch nVidia-SMI. And if you look on GPU 0, it's using 11 gigs of RAM right now. Why would that be? Well, it's because I assigned a virtual GPU to a virtual machine, and it's using around 11 gigabytes of RAM, per the modified profile. All we have to do is wait for Windows to boot up, and then install our NVIDIA drivers. Once you have Windows booted up, you're going to want to go to nvidia.com/drivers and download the Quadro driver that corresponds with your GPU architecture. Yet again, if you have a Maxwell-based GPU like I do, you want to download the Quadro M6000 driver. For Pascal, it's the Quadro P6000. For Volta, it's the Quadro GV100. And for Turing, it's the Quadro RTX 6000. But I've got a Quadro M6000, so we're going to hit search. Now, the latest version from NVIDIA is 511.79, and that is the driver version that I have been testing through this tutorial. There has been an issue in the past with some vGPU unlock tutorials where newer drivers will not work. So keep that in mind if you're following this sometime in the future. This is being tested with the 511.79 driver only. And go ahead and download. Once it's downloaded, I'm just going to run the installer as I normally would. I'm going to click on Custom Installation, click on Next, and we're going to install the graphics driver, and might as well install the RTX Desktop Manager, as it really doesn't alter anything. Click on Next, and hopefully the drivers will install. And just like that, we should have a working Quadro M6000 of sorts with 12 gigabytes of video memory inside of our Windows 10 VM. I'm going to go to the Device Manager. Click on Display Adapters. Here is the built-in virtual machine graphics adapter, and then our Quadro M6000. Success! With the driver fully working, let me go ahead and show you one oddity when working with vGPU systems inside of a virtual machine. So I'm going to right-click on the desktop and go down to Display Settings. And you can see two different displays here, although my window is only showing me one. That is because we are currently looking at the QEMU KVM virtual display. We actually cannot see the Quadro display from this VNC session. So we need another way of accessing this machine where we can see both virtual displays. Now, one option is just using Windows Remote Desktop Client, but I went ahead and installed TightVNC as a server so we can use a third-party VNC client. So I'm just going to get this machine's IP address real quick. 10.0.0.162. Awesome. So we'll go ahead and close out of that window. And then using a TightVNC client, we're going to connect to 10.0.0.162. Now through VNC, you won't get the desktop background, but as you can see, I now have the 1024 by 768 virtual display, which is the built-in VM graphics card, as well as a new 1080p display over on the right side, which is connected to the Quadro graphics card. And to make sure that the Quadro is the primary display, we're going to go down to Display Settings again, and I'm going to disable display number 1. If we scroll all the way to the bottom, we find the multiple displays pull down, and I'm going to say show only on desktop number 2. Keep the changes. And now we are only running the Quadro display. Now, unfortunately, just using a VNC client, you're not able to play games with this because the frame rate is, well, let's just say atrocious. Like, let's go ahead and launch Heaven Benchmark here just so you can see what I'm talking about. So here we have Heaven running. You can see we're getting about 170 FPS, upwards of 220 FPS. But what's displaying through the client is 1 frame per second. So this is obviously not going to fly to connect to for gaming, but there are a couple other clients that you can use. Let's close out of Heaven there. I'm going to install Parsec for right now, which is a very simple client that you can use, and it is web connected, so you can access this PC from anywhere. But in the next video, I'm going to go over a number of different options to stream games from this server to the client of your choice. So make sure you're subscribed so you don't miss that one. With Parsec installed, I'm going to go ahead and connect to that machine now. And this is what the PC looks like when I connect through Parsec. You can see it's a much smoother experience. Everything is moving around pretty much exactly as it should, with as little latency as possible. Now, I can still tell it's streaming from a remote PC, but it's good enough that I can probably play most games. So let's go ahead and relaunch Heaven Benchmark, and let's turn up the settings just a little bit. There we go. And run. Now, I'm only going to be able to do this for a very short time because I don't have my giant fans hooked up to the M40s. So you can see, even just loading the game, we're already at 65 degrees Celsius. And here we are inside Heaven, and you can see that is a much smoother experience. Now, obviously, again, graphics card is already hitting 75. I'm only going to show this for a couple seconds, but we're getting 100, 110 FPS down. There's 160 FPS. Overall, that's a win. But like I said, in the next video, we're going to go over quite a few different streaming options for your game clients and how you can actually use this as a 4-gamer, 1 CPU system for your entire family, household, or friends that live remotely. But that's going to do it for me in today's video. Let me know if you have any questions down in the comment section below. Also in the video description, I'm going to leave a link to the vGPU Unlocked Discord server, where you can talk to the community that is enthusiastic about this kind of thing, as well as the original authors for these 2 vGPU Unlock scripts. On your way down there, make sure to drop this video a like and subscribe to Craft Computing if you haven't done so already. Follow me on Twitter at Craft Computing for daily shenanigans like this. And if you like the content you see on this channel and want to help support me in what I do, consider joining the Patreon. Link is down in the video description. That's going to do it for me in this one. Thank you all so much for watching, and as always, I will see you in the next video. Cheers, guys. Beer for today is from New Image Brewing. It is the Can You Milk an Oat Cream IPA, clocking in at 7.5%. Can I milk a oat? Well, I'm certainly going to try. The great thing about starting a YouTube channel and making craft beer a staple of it is you get to have a craft beer every time you shoot a video. The downside with hiring a cameraman is now it costs me twice as much. That is a delightfully creamy, yet still hazy IPA. Lots and lots of fruit in that. Very juicy. Let me see if I can pick some of those out. Definitely a lot of pineapple right up front. I'm getting a lot of pineapple. Boy, this is going to sound weird, but lemons and passion fruit towards the rear of it. This almost reminds me of, in some ways, a shandy midway through of it. It's got a real similar character to it, where it's a nice, refreshing, like orangeade or lemonade or something like that, with a pretty solid hazy IPA. Recommended. Sorry, 3-point game, 3 minutes left. Yeah, I'm watching basketball. Sue me. There, now I can see the score. I don't have to crane my neck anymore.